Dear students, good morning. Jai Swaminarayan. Welcome to our video lecture. Today, this is an extra lecture uploaded in lieu of holiday. Now, students, the easiest topic of the chapter, and that topic is increasing and decreasing function. For a given function fx, find its derivative f dash x or dy by dx. It is one and the same. All of you know. For a given function fx, find its derivative, students, which is f dash x or which is also called, students, dy by dx. Now you are told that at x is equal to a. It's a given number, a can be 2, a can be 3, like that. At x is equal to a. If f dash a, in the derivative substitute x is equal to a. If f dash a greater than 0, then f is increasing function. And if f dash a less than 0, then f is decreasing function. That's all. This is how, students, we do the sums of increasing and decreasing functions. So, for a given function fx, the first step, students, is to find f dash x, or even I can call it as dy by dx. After finding f dash x at a given value x is equal to a, if you substitute a and if the derivative has a positive value, then f is increasing function. And if the derivative has a negative value, students, then f is a decreasing function. This much only, students, you have to remember for increasing and decreasing function. So today, first of all, section A, we are going to do first 7 MCQs. Come on, students, pay attention now. Today, exercise 5, section A, we are going to do first 7 MCQs. So, the first MCQ, students, I am discussing. It goes like this. What is the formula for derivative of a function fx? All of you know what is the formula to find derivative of a function according to definition. According to definition, f dash x is equal to limit x tends to 0 f of x plus h minus f of x upon h. This is the derivative of a function at a given value x using definition. So, students, here the correct option is C, option C. So, here the answer is option C. This is according to the definition, and this, students, we have already done in students exercise 5.1. Okay, students, now what is dy by dx if y is equal to a x raised to n? Okay, students, the given function is y is equal to a into x raised to n. Now, all of you know, if we have a constant into x term, then derivative dy by dx will be equal to d by dx of a x raised to n. Taking a outside, so this becomes d by dx of x raised to n, and d by dx of x raised to n is n x raised to n So this is the answer. So according to the option, the correct answer is option B. Na x raised to n minus 1. So students, according to the option, the correct answer is option B. Okay. Now let us do the another two MCQs. Next MCQ is students third MCQ, which we are going to discuss. If y is equal to ax plus b, where a and b are constants, then students find dy by dx. Now this is very easy. Or y is equal to ax plus b, given are a and b constants. Given are a and b constants. Fine. Here we have to apply addition working rule. Dy by dx is equal to d by dx of ax plus b. This is equal to a into d by dx of x plus d by dx of b. Derivative of x is 1, derivative of b is 0. So the correct answer is A. So option is also A. The correct option is also A. Fourth MCQ, students, y is given as fx is equal to 4 upon x square. I can take fx as always y, and this is 4 upon x square, which is written as 4x raised to minus 2. Whenever students we have a x term in the denominator, we always students transfer it in the numerator. Now apply the formula. So dy by dx is equal to d by dx of 4 x raised to minus 2. 4 is a constant into d by dx of x raised to minus 2. So this is nothing but minus 4 into means 4 into minus 2 x raised to minus 2 minus 1. So minus 8 x raised to minus 3. So the correct option is B, which is written as minus 8 upon x cube. So according to the option, the correct option is option B. Okay, now let us do MCQ 5, 6. Now students, let us do MCQ 5 and 6. Now students, in the fifth, we are given what is the derivative formula for their product. Okay, product working rule. MCQ 5, y is the function which is product of 2. Y is given as students u into v. So the product rule will be dy by dx is equal to d by dx of u into v. All of you know. First function as it is into derivative of second, always p. Second function as it is into derivative of first. So students, the correct option is option D. The correct answer is students option D. Now sixth is division working rule, where definitely v not equal to 0. Here they have given v upon u. Sorry, the functions they have changed. Okay, no problem. Let us write this as v upon u on the condition that u not equal to 0. You call u, b, x, y, a, b. That has no implication. The main part of the sum is to understand. So dy by dx is equal to by dx of v upon u. Keeping denominator as it is, derivative of numerator as it is into derivative of denominator upon denominator u square. So, according to the option, the correct option is again option D. So, the answer is option D. Now students, the seventh MCQ. Now slowly and formally students, we are going to, you can say, conclude the sections as we do the sums. If the function fx is increasing at x is equal to a, then what is the correct option from the following? For increasing function f dash a greater than 0, we have already written in today's formula. So in the seventh MCQ, the correct answer is f dash of a greater than 0. So the answer is students option B. So 7 MCQs we have done, 3 are pending. That we will do students as and when we complete the respective theoretical topics. Now let us see, or let us do students section B, whatever sums we can. Now section B. Okay students, section B, first question. Define differentiation. Okay, it is not derivative students. Here we are told to define differentiation. The process of finding derivative is called students differentiation. The process of finding derivative students is called differentiation. It is not derivative. We are told to find differentiation. Check on the very first page. We have written the definition of derivative and differentiation. Here you are only told to define differentiation. In one line the definition goes as the process of finding derivative is called differentiation. Means whatever steps we do to find limit, that process is called differentiation. Second, if find f dash x for the function fx is equal to 50. Section B, sum number 1 we have done. Now sum number 2. fx is students given as 50. Now I can call y as fx. I told you this n number of times. So even derivative of f is f dash x is equal to d by dx of 50. 50 is a constant and students derivative of a constant is 0. Third, find dy by dx for y is equal to a raised to n, where a is constant and n is also constant. Here a is also a constant and n will be also a constant. So dy by dx will be d by dx of a raised to n, and derivative of a constant is always 0. Suppose a is 2 and n is 3. 2 cube is 8. Derivative of 8 is a number. Derivative of a number is students 0. Now question 4 and students question 5 we are doing. Question 4 and students question 5. State the rule for derivative for product of two functions of x. Okay, derivative for product. Suppose u and v are functions of x. Let u and v be any two functions of x. So y is equal to u. Do we now all of you know the product rule? Dy by dx, first function second function as it is derivative of first. So students, this is how we write the product working rule. How will be the derivative? How will be the first order derivative of a function at x is equal to a? Function is decreasing. If f dash a less than 0, then f is decreasing. For decreasing function f dash a should be less than 0. That's all. If it was for increasing function, students, then f dash a greater than 0. So you can say this completes our first 5 questions of section B. Then students, we have done question 11, we have done question 12. Okay, now students, we are doing section C. Now students, we are doing few sums of section C. So mark these students, because afterwards, as we complete the respective topics, we complete the respective sums. So in section C, question 1 is define derivative. Now this students, in exercise 5.1 we have already discussed define derivative. So just we are revising the definition once again. Let f be a function defined from a to r. A is any, you can say, open interval subset of R. If small a belongs to capital A and h is a small value such that a plus h also belongs to domain. If limit h tends to 0, f of a plus h minus f of a upon h exists, then the limiting value, answer of limit, is called derivative of f at n value a, students. So derivative of f at n value a is f dash a, and f dash a is nothing but limit h tends to 0. Limit h tends to 0, f of a plus h minus f of a upon h. If it is f dash h, it will be limit h tends to 0, f of x plus h minus f of x upon h. So the process of finding derivative is differentiation. Just now we defined, this is the definition of derivative. Students, write the definition once again. F is a function defined from a to r. Small a belongs to capital A and a is any open interval of r. H is a small value such that a plus h also belongs to domain. If limit h tends to 0, f of a plus h minus f of a upon h exists, limiting value, answer of limit, is called derivative of f at n value a, which is denoted by f dash a. Process of finding derivative is called differentiation. Okay students, now state the division rule for derivative. Okay, suppose y is equal to u upon v, where v not equal to 0. uv are functions of variable x. Then dy by dx, denominator as it is derivative of numerator, numerator as it is derivative of denominator upon denominator square. So this is the division rule which all of you know very well. Now 8 sum we have done, 9 we are doing, 10 we have done, 9 is chain rule. Students, 9 is chain rule. Now all of you pay attention. Y is a function of u, so we can find dy by dt, and u is a function of x, so we can find du by dx. Then dy by dx will be equal to dy by dt into du by dx. Technically du gets cancelled, but you don't have to understand it that particular way. It is understood, students, in a slightly different way as a product. So this is nothing but students' chain rule, and we have done 5 sums of chain rule, students, in section number D. Now, students, pay attention. Question 13 and 14 and 15. I think 15 we have done. Question 13 and 14 of section C, students, I am doing. When can it be said that a function is decreasing at a point? Question 13, answer 13 of section C. Section C, answer 13. And then we are doing sum number 14. When can it be said that the function is decreasing at a point x is equal to if derivative is less than 0? When f dash is less than 0, then we say that f is decreasing at value or point x is equal to a. If a is 2, then if f dash of 2 less than 0, function is decreasing at 2. Like that, students, we can say. Okay, 14, some check whether the function is increasing or decreasing at x is equal to 2. Yes, you are given like this. Y is equal to 12 plus 4x minus 12 plus 4x minus 7x square. And I have to discuss increasing or decreasing at a value x is equal to 2. At which value, students, we have to discuss increasing or decreasing, then it is, students, at x is equal to 2. Now first of all, find f dash x or dy by dx. You can take y is equal to fx is equal to 12 plus 4x minus 7x square. So f dash x is equal to d by dx of 12 plus 4x minus 7x square. So apply addition, subtraction, working rule. Derivative of 12 plus 4 into derivative of x minus 7 into derivative of x square. So this will be 0 plus 4 into 1 minus 7 into 2x. So this will be 4 minus 14x. This derivative, students, all of you know. Now just substitute x is equal to 2. Substituting x is equal to 2. F dash of 2. Wherever there is x is like 2. Sorry, students, 4 minus 14 into 2. So 4 minus 28, which is minus 24, less than 0. If f dash is less than 0, here a is 2. So if the answer of derivative is negative, then f is decreasing at x is equal to 2. So answer I am writing here, f is decreasing at x is equal to 2. So if the answer of derivative is positive, then students, f is increasing, and if the answer of derivative is negative, then f is decreasing. Very easy, students. Most of the time they have asked in short sums the sums of students increasing and decreasing functions. So students, today we have uploaded this as an extra lecture for benefit of, you can say, holiday. Now section D, students, we will be doing questions 16, 17 and 18. Section D, I am writing section D, question number 16. Check whether the function y is equal to, we write function as y is equal to fx is equal to 3x square minus 10x plus 7, and we have to check at two values, x is equal to 1 and x is equal to 2. So students, the algorithm for increasing and decreasing function goes like this. First step, find f dash x or dy by dx. So I am finding f dash x is equal to d by dx of 3x square minus 10x plus 7. So this is equal to 3 into d by dx of x square minus 10 into d by dx of x plus d by dx of 7. So this will be 3 into 2x minus 10 into 1 plus 0. So derivative is 6x minus 10. This is our first step. Find f dash x. For a given function fx, in the theory also students we have done that for a given function fx, the first step is to find f dash x. Now turn by turn take x is equal to 1. Substituting x is equal to 1, f dash of 1 will be 6 into 1 minus 10. So this is minus 4 less than 0. If answer of derivative is negative, f dash of 1 less than 0, therefore f is decreasing. And x is equal to 1. Now substitute x is equal to 2. So f dash of 2 in the derivative, write x is equal to 2, 6 into 2, 12 minus 10, 2, which is greater than 0. So write like this, f dash of 2 greater than 0, therefore f is increasing and x is equal to 2. This is your answer. This sum is asked for 3 marks, students, in board examination. This sum, students, is asked for 3 marks in board examination. Okay, now let us do sum number 17. Yes, students, now we are doing sum number 17. The function is y is equal to 2x cubed minus 7x square. The function is y is equal to 2x cubed minus 7x square plus minus 11x plus 5, and the values at which we have to check are at x is equal to 1 by 2, at x is equal to 1 by 2, and at x is equal to 3. So now I suppose all of you are well versed. The first step, now I suppose students all of you are very well versed. The first step is to find f dash x or dy by dx. So we write y is equal to fx is equal to 2x cubed minus 7x square minus 11x plus 5. So f dash x is equal to d by dx of 2x cubed minus 7x square minus 11x plus 5. Now students, all of you have to apply addition, subtraction, working rule. So 2 into d by dx of x cubed minus 7 into d by dx of x square minus 11 into d by dx of x plus d by dx of 5. So this is 2 into 3x square, 7 into 2x minus 11 into 1 plus 0. So this will be 6x square minus 14x minus 11. So this is, students, the answer of f dash x. Now, turn by turn, we have to substitute the given values and check whether the derivative is positive or negative. That much only, students, you have to check. So substituting x is equal to 1 by 2, we get f dash of 1 by 2 will be 6 into 1 by 2 square will be 1 by 4 minus 14 into 1 by 2 minus 11. So this will be 3 by 2 minus 7 minus 11. So this will be 3 by 2 minus 80. 3 minus 36 divided by 2. So minus 33 by 2 less than 0. So f dash of 1 by 2 less than 0. Therefore f is decreasing at x is equal to 1 by 2. Now for 3 I am writing here, substituting x is equal to 3, f dash of 3 will be 6 into 3 square is 9, 14 into 3, so minus 11, 6 9s are 54 minus 42 minus 11. Now students, pay attention, 6 into 9, 54, 14 3s are 42. So this is 54 minus 53, 1 which is greater than 0. So f dash of 3 greater than 0. So f is increasing at x is equal to 3. This is our final answer for the sum number 17. Now students, pay attention. The last question, sum number 18. Here I am writing derivative and then you have to just check, students, whether it is increasing or decreasing. I suppose all of you can easily do sum number 18 in homework. I hope, students, very easily you can do sum number 18. So I am leaving dy by dx will be 2 minus 14x. In 18 sum, f dash x I am directly writing it will be 2 minus 14x. Now remaining, you have to check by substituting 4 and minus 4. I think all of you can very easily do on your own. Okay students, here we conclude the lecture. 18 sum I suppose you can easily complete by taking x is equal to minus 4 and x is equal to 4. Okay, thank you students, study well.